Thank you very much for this opportunity. Good morning, everyone. So we're going to talk about automation of the network here with Mist Systems. With Mist, we've always taken immense pride in the fact that every single command, every single thing that you do on the UI is 100% API. The system was built in with API in mind first and UI built on top of it. We've said the story a lot of times. You go into your dashboard, you right-click, inspect element. You can actually click a button. You can see the API call that is being made. So every single button out there is an API call, a huge documentation available for APIs. And there's more stuff available in the APIs than the UI. That's the story we've had until now. But what we wanted to go through this presentation is, it's not just a story of having APIs. We wanted to showcase today as to how customers use APIs and how they've actually used APIs for two things. One, help with rapid deployment. Two, the most important part of it, get cost savings out of it. So with that, we'll talk about a couple of things. And we've planned this session having APIs in mind throughout the deployment of a wireless network. Starting from day 0, where you could provision, then day 1, we're actually hooking up APs into the ceiling, and then go on to day 2 and on later on, as in you do the operations with alerting, monitoring, and troubleshooting. Day 0 is when you can actually, without having equipment in your system, you are able to configure or set up an organization. At Mist, the hierarchy is simple. You have an organization, you have sites under them. You'd be able to create organizations, create sites, create your configuration template, have it all ready to go from the day 0 before the day of actually having to be going into deployment. You don't have anything hooked up. Day 1 is when we are talking about access points being actually placed on the network and how they actually inherit configuration. Day 2 is when the most important aspect of all of this comes into picture. The Marvis actions we spoke about, anomaly detection we spoke about, all of this automated, so you don't have to sit there and actually browse through dashboards after dashboards for you to actually go through to see whether your site has a problem. And we talk about proactive monitoring, wherein you don't wait until the user opens a ticket. You use the cloud-based architecture, which gives you the advantage of having AI built in for you to get Marvis actions, for you to get anomaly detection, to provide the kind of level of service you'd like to give. With that, let's talk about the day 0 automated provisioning.
Yeah, so day 0, you just sold a project or you're starting a project. You need to get set up. We have 2 stages in this. The first stage is your manual configuration. You're actually going in, you're creating your templates. We operate on a hierarchical design, so everything gets inherited. So this step, the manual process of creating your RF parameter templates, your device profiles, the global templates, and everything that's going into your sites and controlling your access points, how they're configured. That is a manual process, unfortunately, still. Going on from there, we can automate the rest using our API. And the way we're doing it right now, like Abhi said, we're not going to dive in too deep. We're going to tell you how we're doing it in the real world. So I'm working with a customer right now that's going through a deployment of hundreds of sites. We're doing dozens a week. And what they're doing is we have this done. This was done months ago, very early in the sales cycle, because usually this is done in your labs. You're validating your configs, and then you're pushing it into production. So moving over to the automatic site creation, we have a partner that we're working with who's doing staging. They get the access points, they unpack them, they test them, they scan them in, they put an asset tag on, and then they ship them out to the site. When they do that, they're able to provide me with a CSV file of the MAC address, the host name, the site. And based on that, I'm automatically creating the sites, automatically configuring the sites based on the templates, because there are 3 different types of offices. They have small office, medium, warehouse, that kind of thing. So that's all getting automatically configured. And the automatic upload of site maps, we don't have that in this flow that I'm doing, but I have another customer that I'm working with that we do that through a migration. So they're providing me with the CSV file, hundreds of records. I run a script, and the new sites are created. The new access points are assigned. Everything's configured, and as soon as those installers plug them in, everything comes up. The site's alive. That's it. As far as the rest of the network that's being deployed at those locations, we, hopefully we'll get more involved with that. But right now, the wireless, the deployment of that is going very, very quickly, easy, and not even a headache. Probably 5 to 10 minutes a week I'm spending on hundreds of sites being deployed over the past 2 months. So we could actually make it go even better. We have a video of the 500 sites in 5 minutes.
Yeah, so here's a quick example of how we are able to create organizations, create configurations, and that's the steps we said, which will be automated. But here's where we said the customer supplies us with site names, site addresses, and any other information that is necessary to create a site. All of that, that's a very simple CSV file of their all 500 sites. It's a very simple Python script. You import the CSV, you have the sites created on the Mist dashboard in no time. And that's the point of, so there are two aspects to it. One, it's error-free. Two, it's a mundane process which doesn't need to be done by somebody sitting there creating one site after the other. So that's the power of automation. You'll be able to get sites created under no time. Now, Ryan just spoke about an aspect of it. We receive MAC addresses of APs and getting them which exact site they go to so they inherit the exact configuration where they have to get into. How about we take that aspect out of it as well and make it further automated from there on? So one of the things that happens with all of our APs that go onto the network, always go associate to a switch. And all of these switches always speak with us for LLDP. We do that for power negotiation. All of these switches, with majority of the IT admins out there, they have a strong discipline out there to name the switches according to the site they belong to. We have this much information out there already. So what we've done is taken automation to a next level. You can just plug in an AP. The AP negotiates to the switch it is connected to, gets the switch name that it's connected to, automatically gets assigned to a site based on the switch name it is associated to. So that's the next level of automation we are taking it to now. You're taking away all the amount of CSV work wherein you have to send Ryan with the whole amount of CSV saying this is the MAC, this is the site it would go to, takes it out of the picture and have the APs directly associated to it.
Now, is that only with Juniper products?
No, it's all switches, yes.
Yeah, and it's not just LLDP. You can see down on the bottom left there, we can do it based on IP address. There's a whole range of fields that we can use and different ways we can use it to automatically assign and even name the access points.
So just for the hell of it, this is now built in. We built this ourselves when we initially deployed Mist. And that was kind of the first time we started playing around with the API. That was the result. It took us a day to write this functionality just because the API is fairly well formed. So this was just a Python script that reads in a configuration file that associates a regex for the LLDP switch name with a site ID. It then installs a webhook that basically gets inbound events every time. So when you buy Mist APs, you get a claim code. So if you have an order of 2,000 APs, you enter one string and now 2,000 APs with their MAC addresses, serial numbers, whatever are assigned to you. We created a site called installation site that we assign all new APs to. They're unstaged. In that site, all WLANs are turned off. That's just to prevent APs from starting to broadcast stuff while the rest isn't configured yet, right? Then a webhook basically receives notifications when an AP joins the cloud in that installation site. From there, it actually goes out, and we're still using this because of the following step. It goes and actually checks that the switch uplink port is configured correctly. We manage everything in Netbox and then push out via Ansible or Python script, so that's fairly easy for us to check. If the uplink port is not configured correctly, we go and configure the uplink port. At that point, the AP reboots, joins again, process starts anew. We then check the firmware and upgrade it to our current production version, and then based on the LLDP name on the regex match, assigns it to the site. At that point, immediately radios are enabled, WLANs are there, and the AP is fully in service. The last thing we then do is we have technicians walk through the building when it's done, and use the iOS app just to name the APs and place them on a map. But for us, handling APs is down from about an hour per technician, an hour for a technician to go and install an AP, unbox it, get it configured on the controller, etc. To we no longer do any of that. We use wiring contractors to pull the actual wires into the ceiling, and the wiring contractors just get access to a room with pallets full of Mist APs. They grab whatever they want, install it, it comes up into service. Done.
That's a very powerful story. It comes in twofold. So one of the things that about that story is automation is not just the IT admin's job. It starts all the way from the low voltage contractor all the way till the IT operations and anyone in between. And that's what is powerful about that story. And if everybody does deployment like Felix does, then our missing VLANs feature kind of becomes obsolete, I guess, because you're constantly.
I like the double check.
You like, yeah. So assigning APs to a site, not only LLDP name is one of the ways. If you are a really big campus, if you're having different subnets across different buildings out there, you could use your subnets as well for you to assign APs. So we started off with the day zero aspect of it, where we created sites, where we created RF templates, config templates. Now we have assigned APs to the site. The next aspect would be to name the APs. You could actually name the APs automatically as well. So you could actually use the LLDP port description, and if you could put in your LLDP port description as your AP name, we grab that and we actually name the APs for you. So that's the AP name aspect of it. The last step of the flow, that would be in this entire journey of day zero and day one, with Mist especially, is for you being able to actually place these APs on a map, so you can actually see where the users are, or if you're doing anything location-based. So that's the next level of automation that Ryan's going to actually demo this to us right now.
So I'm going to break all the rules and do a live demo.
No, not this crowd. I'm sorry, who are you?
So, I mean, we've all worked in Ekahau. Most of the wireless guys here. There's a workflow. There's a workflow that's oftentimes really hard to nail down. It's individual to an organization. It can be a real pain to manage. Which is the single source of truth. A lot of people, probably a few in this room, believe that Ekahau should be the source of truth for all of that. For wireless location of the access points, and it should be maintained that way. So, what if we could use Ekahau as the single source of truth? I have a few projects here. Let's see. Open up the US one. As you can see, we have an access point, a single access point, with an access point name and a MAC address. This is a predictive model. When you're doing 1,000 sites, it's often hard to do full surveys until after the installation. So you have a team that does designs and then does remediation afterwards for anything that's going on, any issues that pop up. But what we have here is, say during the design process, this goes into the staging team. Staging team fills in the MAC address there in the AP name before they ship it off to a site. So similar to the scanning process, this is a very proof of concept workflow. So that could even be streamlined with a tool that automatically adds that in. We have an organization that has claimed the access points. See, there's two there. We have RF templates based on country. And we have WLAN in our organizational config. So this will inherit down to the entire organization, all sites underneath it. And we just have a demo site that's in there, in the lab. Like I said earlier, a lot of these go through the lab before becoming reality. So what can we do with this? Well, I wrote some scripts, and this is It's not a whole lot of code. It's these two files. That's it. These two files here run everything you're about to see. So we can tear apart the Ekahau file. We can load the access points, the floor plans, the project info. And let's check out the project info. So there's nothing crazy in here. We have an address, customer name, project name. Project name oftentimes can be correlated to a site name. So why don't we correlate that to a site? Verify that we're reading it incorrectly. So this isn't Ekahau anymore. This is in Python. We have read it correctly. That access point is placed properly. Push it to the cloud. You notice there was no site on here. And now there is. Not only is there a site, it has the correct RF template. It has, there we go. It has the map that is properly scaled with an access point claimed on it and named. So we can do that. That's not too bad. That works. That's pretty nice to be able to do that on a site-by-site basis. But what if we want to do a bunch? I have to roll this back. So you saw I have multiple sites in there. I'm unassigning the AP, so we're going back to scratch. I'm going to delete this site completely. You see over here, we have 3, Australia, Canada, US. Same setup, Canada has an access point. Australia has 2 floor plans, has 2 maps. It's a 2-story building. No access points deployed to them yet, so right now, we're just gonna take that and we're gonna read that whole folder as opposed to just an individual file, and we're gonna loop through that. See, we're loading the info, getting the access points, the floor plans, verify that information, make sure it all reads out properly. And it looks good. Check the maps. Yep. US and Canada both have the access point placed. You see Sydney has 2 floors. And now we're going to send that up. And it's creating the sites. There we go. So from scratch, like I said, we create the templates at the organizational level, usually done during the proof of concept phase. That's a very manual process where you're tuning it to get it right for your network. From there, we can just take the source of truth that you're already using, and you can see I threw this together in a few hours, Sunday morning. This is what we can do, and it's not, you're not limited by waiting for us to add these features. You can go in and add the features yourself. This is the kind of stuff that we can do, and this is why I wanted to join Mist so much. So you can see.
You got a couple examples, that obviously wrote. Just based on what you said earlier, I'm assuming the API is documented. Do you guys have like repositories of examples or things where to help people get started?
There are some examples up on GitHub. I want to start releasing more, but this is not ready to be released. So
I do. A lot of times we talk about the capabilities,
yeah.
And that's great. But we know we're kind of in this transition phase
Yep.
for automation.
And that's why
get geared up.
That's why we didn't just want to walk through the API docs today.
Yeah.
We want to show you that it's actually being used, how we're doing it, and the things that could potentially come from the future with it.
And
so.
they mentioned kind of, right, this is a lot like AWS, like the GUI is API driven. Like most of the programming we did, the docs are good. I have no complaints about the docs. Yep. But what we really do is we just go do it in the GUI and go through,
watch what calls you're making. Yep.
Just the network trace of the post gets put. It's an extremely well-formed API in my opinion. I get very upset at APIs that require me to do all sorts of crazy stuff. This one is sane. And just looking at what the actual GUI does, in most cases, in minutes, you can pick up what you want to do.
Yeah, everything's linked together. That hierarchy really shows when you start looking at the API. You can really see how everything ties back together because there are reference points to all the different components of the back end in practically every object that we have out there. And as far as documentation goes, you do need an account to log in, but we have it all here. It's very well documented.
That's one of the things that bothers me like crazy. Just as feedback, documentation shouldn't be behind a registration wall. Like if I'm considering your product, I should be able to see your documentation to see what the actual involvement is to use your product, right? So just as feedback from somebody who does this with lots of different people, you're not the only one who does this, so I'm not pointing the finger only at you, but it is like documentation should be available to people without having to log in.
Yeah, I don't disagree.
Definitely.
What documentation is.
Yep.
So this is just
Yeah, this is the actual API browser. Mist.com documentation, that's firmware. We do have a lot of documentation out there where you can get to it without being behind a paywall or behind an account. Yeah. We also have, if you do have an account and you want to see what you're going to get from the API, you can browse the framework. So you can actually do all your API calls right through this and see what you're going to get back. So this is part of the crawl, walk, run process. Here you're going to see, okay, here's all my sites, here's all the links, here's the info I'm going to get back, and now how do I work with that data? So I think this kind of falls in the walk area. Yep. So.
That was uber cool. All of that without actually going onto the Mist dashboard, just using Ekahau ESX files, and you had your scripts running, and your sites were created. All your day 0 through day 1 were completed just through scripts. With that, we'd like to get into the day 2 part of it, which is the bulk of what we would do after a particular deployment. So we've divided that into 3 pieces: alerting, monitoring, and troubleshooting. Alerting, again, the advantage of bringing in Mist is where the modern cloud comes in picture. There is tons of data in the cloud, and you could actually alert any subsystem out there. There is a Splunk, a ServiceNow, open tickets automatically with ServiceNow, things like that, using our alerting-based framework. You could also use webhooks. Webhooks are asynchronous calls made by us to your listening webhook, wherein if an AP goes down, if your DHCP server is not responding, DNS server is not responding, things like these can actually be alerted to you onto your, if you're listening to our webhook, without us constantly streaming anything. We also alert over emails. You could get emails over it. I think the most thing I'm really excited about how you'd be able to monitor going forward. We distill a lot of data that comes to the cloud, and we present it to you in the form of SLEs. SLEs are our definition of how your user experience is at any given point of time, on a per client basis, on a per site basis, on a per org basis, all 3 aspects of it. With this, you are able to actually simply call basic API calls to say, how is my throughput SLE doing? How is my successful connect SLE doing? And you actually could hold yourself responsible, accountable to say, my SLE should be 90% or above. If it is below 90%, open a ticket automatically. And that could be a true case for proactive monitoring. And that's where we talk about service level expectations being our holy grail to see how your network's doing. If you don't just like the SLEs, we go 1 notch up. If your SLEs aren't doing well the way they were doing based on our baseline, we detect anomalies on them. So we could actually not just monitor SLEs, you could just subscribe for anomaly detection events. We could send you anomaly detection events, and you could directly open tickets. We are 100% sure that if our system detects an anomaly, it is absolutely a problem that needs to be addressed. So that's the monitoring aspect of it. So you could you could integrate the anomaly detection webhook into your ticketing system and be rest assured that we will proactively send you anomaly alerts which you could take action on. Troubleshooting, obviously, I think we've spoken enough about it in this session. You have Marvis to troubleshoot. We also have dynamic packet capture. If Marvis tells you an answer, you don't like it, we have actual evidence to say, here's the packet capture, and it's the truth. So that's how you could actually take.
So what you're saying, you get you an argument for Marvis and Marvis will win?
Packet capture will win, the data will win. Marvis most probably will win if you get into an argument, yeah. So what we want you to take away from all of this is, going forward, I think the best way to monitor your network is just being able to monitor these two things. Marvis actions, we spoke about Marvis actions as to how we will be able to tell you what the problem is and what's the next level of action. And if your users are having a bad experience, anomaly detection will take you home in order for you to say, there's a problem, we'll need to fix this, here's the change of the, what changed, here's the successful anomaly, successful connect anomaly that has happened. If you've liked everything that we've shown here, I'm pretty sure you would like to actually learn about more of this. And I guess that was one of the questions as to where is this documented, how do we get to the process? So with the UI, you're crawling. I really like a tool called Postman. It's a very simple tool where you can actually converse API changes, and you could use that. And we have a full-blown documentation of how to use Postman from the point of setting it up. So you could very comfortably walk with that. You could. Ryan also showed the Django framework, how easily you can walk. And this is the best part. The API class.mist.com has real-world examples of site creation. You wouldn't need to download Python to run this because we have an inbuilt Python runner. If you'd like to, take a picture of this link, I'm sure you'd like to check this out. You have hands-on labs as to how, from the point of how APIs are built to the point of how you could run simple scripts to make your network run.